China's submersible is carrying out its latest mission at the Mariana Trench in the Pacific Ocean.
31,000 feet beneath the Pacific, a robot entered a world where sunlight dies, pressure crushes steel, and life should barely exist. Scientists expected mud, rock, and a few starving scavengers. Instead, its lights revealed something impossible: entire colonies thriving in total darkness, powered not by the sun, but by poison leaking from the earth itself. The place life was never supposed to flourish. To understand why this footage shocked scientists, you have to understand where the robot went. This was the Hadal zone, the deepest region of the ocean, named after Hades, the ancient Greek underworld. The name fits almost too well. These trenches are not just deep water. They are wounds in the planet, carved where tectonic plates collide and one slab of Earth's crust is dragged beneath another. The result is a landscape more extreme than almost anywhere on Earth. At these depths, the ocean becomes less like water and more like a crushing force. Pressure rises to more than 1,000 times what we feel at sea level. Every square inch is squeezed with enough force to destroy ordinary submarines, crush unprotected equipment, and make human survival impossible without specialized engineering. There is no sunlight, not dim light, not blue twilight. Nothing. The last photon from the surface disappears long before it gets anywhere close to the trench floor. Down here, there are no plants, no coral reefs glowing in the shallows, no algae turning sunlight into food. The temperature stays just above freezing. The darkness is permanent. The pressure is monstrous. The landscape is cut off from the warm, bright world we usually associate with life. So for a long time, scientists assumed the deepest trenches could only support life in small, desperate amounts. The standard explanation was marine snow. That is the name for dead organic material that falls from the upper ocean. Bits of plankton, waste, dead animals, and microscopic debris drifting down like a slow-motion blizzard. In most of the deep sea, that falling material is the main food source. Life at the bottom survives on leftovers from the sunlit world above. That was the model. A few scavengers, a few microbes, a few strange fish. Life clinging on, but barely. Then scientists sent the submersible down. And the footage did not show a starving world. It showed a world that had found another way to live. As the light swept across the trench floor, the cameras recorded dense communities of organisms packed into areas where almost nothing should have been able to grow. Tube worms stood in clusters like pale underwater grass. Bivalves were buried in sediment. Shrimp and other crustaceans moved across the seabed. Microbial mats spread like ghostly patches across the mud. This was not one lucky pocket of survival. It was an ecosystem. And that is what left everyone speechless. Because an ecosystem needs energy. It needs a base. It needs something feeding the life above it. But in this place, there was no sunlight, and the communities were too dense to be explained by scraps falling from above. The food chain was alive. But the sun was missing. The ecosystem that broke the rule. On the surface, nearly every food chain begins with photosynthesis. Sunlight hits a plant. The plant turns that light into chemical energy. An animal eats the plant. Another animal eats that animal. Even predators that never touch a leaf are still connected to sunlight through the chain beneath them. That is the rule most of us learn in school. But the world at 31,000 feet does not follow that rule. The trench communities discovered by the submersible were powered by chemosynthesis. Instead of sunlight, the base of the food chain came from chemicals seeping out of the seafloor, especially methane and hydrogen sulfide. To us, those chemicals sound dangerous. Hydrogen sulfide is toxic. Methane is flammable. These are not things most surface animals can use as food. But in the deep ocean, specialized microbes have evolved to turn those chemicals into energy. They do the job plants do on land, but without light. That is the breakthrough. Down here, life does not begin with the sun. It begins with the earth itself. Fluids rise through cracks in the seafloor, carrying methane and hydrogen sulfide from deeper geological processes. Microbes consume those chemicals and convert them into organic matter. Tube worms and clams can live with symbiotic bacteria that help process this chemical energy. Other animals then feed around those communities, building a full ecosystem where biology and geology are locked together. The trench floor becomes a kind of dark garden, not planted in soil, but rooted in chemistry. That is why the footage mattered so much. Scientists were not just looking at a few weird deep-sea animals. They were looking at a second model for life on Earth. The first model is the one we know: sunlight, photosynthesis, plants, oxygen, food chains. The second model is stranger: darkness, pressure, toxic chemicals, microbes, chemosynthesis, animals built around invisible energy. This is the original twist. The robot did not simply discover life in a deep place. It discovered that Earth has two engines of life. One engine runs from above, powered by the sun. The other runs from below, powered by chemicals leaking out of the planet. That changes the emotional weight of the footage. Those tube worms and clams are not just bizarre creatures surviving where they should not. It does not wait for perfect conditions. It finds cracks, chemistry, heat, gas, pressure, sediment, and darkness, then builds a world out of whatever is available. For years, people described the deepest trenches like deserts, but the robot found oases. And the most unsettling part is that these oases may not be rare. The expedition documented communities across a huge stretch of trench system, not just one isolated site. That suggests scientists may have underestimated how common chemosynthetic life is in the deepest parts of the ocean. How much life is down there that no camera has ever seen. The footage that made Earth look alien. The deeper the robot went, the less Earth-like the footage became. There were no familiar colors, no sunlight rippling across sand, no plants swaying in current, no reef fish, no ordinary horizon. Just black water, pale animals, strange mats of bacteria, and sediment under lights that made the trench look like another planet. That is why the discovery immediately caught the attention of astrobiologists. If life can exist here, in darkness, under crushing pressure, feeding on chemical energy, then Earth's deep trenches become more than marine habitats. They become training grounds for the search for alien life. Two places matter most: Europa and Enceladus. Europa, a moon of Jupiter, is believed to have a deep ocean beneath its icy shell. Enceladus, a moon of Saturn, shoots plumes of water vapor into space, suggesting an ocean hidden under its frozen crust. On their surfaces, these moons look dead, frozen, bright, hostile. That combination is exactly what makes scientists pay attention. Life on Earth does not need sunlight if it has the right chemistry. That means the most promising places for alien life may not be planets with sunny beaches or green forests. They may be buried oceans where chemical reactions feed microbes in darkness. The trench footage gives scientists a working analogy. Not proof of aliens, but proof of possibility. That matters because our imagination has often been too narrow. But the deep ocean shows that life may not care about the kind of comfort humans need. It may care about energy, water, chemistry, and time. That is why the discovery feels almost cosmic. A robot went downward, not upward. It did not stare through a telescope into space. It descended into Earth's own darkness, and there, at the bottom of the ocean, it found a clue about where life might exist elsewhere in the solar system. The alien world was not above us. It was beneath us. This is the part that gives the story its power. The deepest ocean is not just unknown because it is hard to reach. It is unknown because it forces us to rethink what life is allowed to be. Every creature in that footage is a challenge to our assumptions. Every clam, worm, shrimp, and microbial mat is saying the same thing. Do not confuse sunlight with life. Do not confuse darkness with emptiness. Do not assume a place is dead because humans cannot survive there. The footage left scientists speechless because it showed life doing what life has always done, refusing to obey the limits we set for it. The deep ocean is still almost unseen. Here is the part that should disturb everyone. We have explored space more confidently than we have explored much of our own deep ocean. Humanity has mapped planets, landed machines on Mars, photographed galaxies, and listened for signals from beyond the solar system. But most of the deep ocean floor has never been visually observed by human eyes or cameras. Sonar can map shape, but it cannot tell us what is alive down there. It can show ridges, trenches, slopes, and seamounts, but it cannot reveal a colony of tube worms hidden in black water. That is why each dive can rewrite science. The deep ocean is not a finished textbook. It is an unopened archive. Every time a vehicle descends into a new region, researchers risk finding something that does not match the old model. New microbes, new animals, new feeding strategies, new geological systems, new forms of adaptation, creatures that tolerate pressure in ways scientists still do not fully understand. Even small deep-sea animals can reveal enormous biological surprises. Some deep-living crustaceans use compounds that help protect their proteins under pressure. For years, scientists assumed those protective compounds would increase steadily as depth increased. But real animals do not always follow our models. Some survive at pressures that should disrupt their cells without matching the expected chemical pattern, suggesting unknown adaptations still waiting to be studied. That is the recurring theme. The deep ocean keeps refusing to behave like the simplified version of itself. And that matters because the Hadal zone is not one place. It is a global system of trenches scattered across the planet. If chemosynthetic communities can exist across huge stretches of one trench system, then other trenches may be hiding their own networks of life. Some could be similar, others could be completely different. That is the problem and the wonder. We do not know because we have barely looked. The robot's footage is not the ending of the story. It is the first page of a much larger one. Scientists are not just asking, "What did we find?" They are asking, how many ecosystems have been living down there all along while we call the deep ocean empty? The answer could change biology, medicine, climate science, and astrobiology. Deep-sea organisms produce unusual compounds that can inspire new medical research. Deep ocean circulation affects climate. Microbes in extreme environments help scientists understand the boundaries of life. Every new discovery is connected to questions far beyond the ocean itself. That is why the footage matters, even if you never go near the sea. The deep ocean is not separate from your world. It helps regulate the planet you live on, and we understand only a fraction of it. The world we found just as we started damaging it. The most painful part of this discovery is the timing. Scientists are finding new deep-sea ecosystems at the exact moment human activity is reaching them. Microplastics have already been detected in the deepest parts of the ocean. Tiny fragments of plastic have traveled from surface waste into trenches that most people will never see. Animals living under some of the most extreme conditions on Earth are already encountering human pollution. Think about that. A creature can survive freezing darkness, crushing pressure, and toxic chemistry, but it cannot escape plastic from the surface. That image should stay with you. But pollution proved that there is no true away on Earth. What humans throw into rivers, coastlines, shipping lanes, and open water can eventually move through the system and settle where no person has ever stood. And plastic is only one threat. Deep-sea mining is becoming one of the biggest questions in ocean science. Companies and governments are interested in mineral deposits on the seafloor. They also provide habitat for deep-sea life. Scraping them up is not like harvesting a crop. On human time scales, once they are gone, they are gone. Mining could stir sediment plumes, damage habitats, disrupt food webs, and destroy organisms scientists have not even named yet. The frightening part is that some of the areas being discussed for future extraction are close to or within deep-sea environments that remain poorly understood. That creates a moral problem. We are preparing to industrialize parts of the ocean floor before we have fully explored them. The robot's footage turns that from an abstract debate into something visible. It is much harder to call the deep ocean empty when you have seen tube worm forests and clam beds thriving in darkness. It is much harder to treat the seafloor as a mineral warehouse when you realize it may be one of the most mysterious living systems on Earth. This is where the script shifts from wonder to warning. The same discovery that expands our imagination also exposes our carelessness. We found life where we thought life should not exist. Then we realized our pollution had already arrived there first. That is the human contradiction. We reach the deepest places with science, but also with waste. We send robots to understand and industries to extract. We celebrate the footage, then risk destroying the world inside it. What the robot really showed us. So what did the robot really find 31,000 feet below the surface? Not just animals, not just bacteria, not just a strange trench ecosystem. It found a different answer to one of the oldest questions in science. What does life need? For a long time, the answer seemed obvious. Life needed sunlight, at least indirectly. It needed warmth, food, oxygen, and a stable environment. But the trench says something else. Life needs energy, chemistry, and time. The form can be almost unrecognizable. The environment can be hostile. The food chain can begin with poison. The world can be black, frozen, and crushing, and life can still build a community. That is the real discovery. The footage is not shocking because it shows monsters. It is shocking because it shows confidence. Those creatures are not barely surviving. They are living in the only world they know. They are adapted to pressure that would kill us instantly. They are attached to chemical flows that would mean danger at the surface. They are part of a system so old and isolated that humans arrived like strangers shining lights into someone else's city. That image changes the way we should see Earth. Our planet is not one biosphere. It is layers of life, stacked across light and darkness, surface and depth, photosynthesis and chemosynthesis. The green world above is only the version we know best. Beneath it is another world, slower, stranger, and almost completely hidden. The robot did not reveal an exception. It revealed a second pattern. And if that pattern exists across Earth's trenches, it may be one of the most important biological discoveries of our time, because it means life is not as fragile as we thought in one sense, but more vulnerable in another. Life can survive pressure, darkness, cold, and poison, but it may not survive human ignorance. That is the final twist. The deep ocean's greatest danger may not be the crushing pressure, the darkness, or the toxic chemicals. The creatures down there already mastered those. The danger is us reaching them before we understand them. We are standing at a strange moment in history. For the first time, technology allows us to see the deepest ecosystems on Earth. Cameras can go where sunlight cannot. Submersibles can cross trenches that once existed only as numbers on maps. Scientists can sample microbes, measure chemicals, and film animals living in a world that looks more alien than anything on land. But technology also gives us the power to damage those places faster than science can explain them. That is why the footage left everyone speechless. It was beautiful. It was impossible. And it was fragile. A robot went to the bottom of the ocean and found life where textbooks once expected emptiness. It found a food chain without sunlight. It found chemistry doing the work of the sun. It found a blueprint for possible life beyond Earth. And it found all of this in a world humanity has barely begun to see, but has already begun to pollute. The question is no longer whether life can exist in the deepest darkness. The footage answered that. The real question is whether we can protect it long enough to learn what it has been trying to tell us. Scientists sent a robot into darkness and found a living world powered by chemistry, not sunlight. It may change how we search for life on Earth and beyond. Like this video, subscribe to the channel, and comment. Should deep-sea mining be stopped before we understand what lies down there?